follow same mechanism. The reason is if AP South 1A is down, you have another public subnet in AP South 1B. Okay, you can use that. Okay. So if one private subnet down also, for example, if you put AP South 1A in public subnet, 1B in a private subnet in 1B, you have taken only one subnet and one subnet. So if something happened to 1A, all your public subnet resource gone. If something happened to 1B, all your private resources gone, right? So to not get into such type of things, so it's recommended to spread our resources across multiple public subnet as well as private subnets. Okay. So this we always follow. Okay. So yeah, any questions on previous session? No questions? Not practiced? Practiced? Okay, good. So if you have anything, we will discuss. I'll start session by 9:05. We have 4 minutes. We can discuss anything. Okay, what is today's breakfast? Dosa. Okay, masala dosa, rava dosa, ghee masala dosa. What? Ask me something, guys. Okay, I'll do one thing. I'll prepare this private subnets. So yesterday we created only these 2 subnets, right? Okay. So we created this one, I believe this one. 0 and 32 we have created. So let me go here. These are the subnets. Right. So this is a public subnet 0.0/19. So this is a public subnet. Private subnet is 32.0. Okay. This is a private subnet, but there I have created it in AP South 1B. So this is valid now. Okay. So now I'm going to create a public subnet. Click on create subnet within my custom VPC. I'm calling it as the public subnet 1B. I'm creating this subnet in AP South 1B. And what is the CIDR range? The 172.84.0/64.0/19. Okay. So then I'm going to add new subnet. I'm going to call this as a this is a public subnet 1B. This is private subnet 1A. I'm creating it in AP South 1A. /19 is a subnet. Then create. So now what happened? We have 2 subnets in AP South 1A, 2 subnets in AP South 1B. Okay, I will modify it accordingly. Okay, I have 2. Okay. This is the one, right? 1 second, I'll correct it. Public subnet 1 in 1A, public subnet 2 in 1B. This is a private subnet in 1B, private subnet in 1A, private subnet 2 in 1B. So now you see, I have two public subnets and two private subnets. So one public subnet is in 1A, another private subnet is in 1A, one more public subnet and one more in both in 1B. So now we are matching with this diagram. Okay, so quickly I'll launch EC2 instance and I'll keep it ready for today's session. So yesterday what we did, we have taken two Windows instances, right? So today I'm going to take Jump server as a Windows and my private subnet instance as a Linux. Okay. Instances, launch instance. I'm going to call this as a Jump server today. Or you can even call it as the Bastion host. I'm taking Windows Server 2016 base, T2 micro. I'm selecting a key pair, my Windows key pair, custom VPC, public subnet. We are good with it. And I'm going to select a Windows SG we have created. Then launch instance. So we have launched the Jump server or Bastion host. See, okay, we have created two subnets here, but did we associate it to any root table? Then will it work? No, right? So you guys missed that and I'm also missed that. Okay, so what we need to do, go to root table, navigate to public root. So what we need to do, subnet associations, edit subnet association, select public subnet to associate. So it already have root via internet gateway, so it become public. And navigate to private root, subnet association, edit subnet association, private subnet, then save associations. So both private subnets are with private root table that don't have any root via internet gateway. Both public subnets are with public root that have root via internet gateway. So whatever instances you are going to launch, it can access over the internet if you have public IP address. And we can access internet from that EC2 instance also. Okay. Right. So here I launched a EC2 instance in public subnet. So let me quickly launch another EC2 instance in private subnet. Launch instance, I'm calling it this as a private subnet instance. I'm going to take Amazon Linux. I'm taking Amazon Linux T2 micro key pair as a my Linux KP, and I'm going to launch this in one of the private subnet. And do we really require public IP address? Even if you gave public IP address also, no use, right? Yesterday we did that. Okay, I'm going to create a new security group. I'll call this as a Linux SG. Port number 22 is open for everyone. We are good with it. So now we have one EC2 instance in public subnet. We have another EC2 instance in private subnet. So if I want to get connected to private subnet, what we need to do? You first get connected to Jump server or Bastion host. From that machine, you get connected to private subnet instance. That is what we have performed in our last session. So till here, we discussed yesterday things only, nothing new. Okay. So let's quickly get connected to it. I'm grabbing public IP address. I'm using this remote desktop tool. Add PC. Given the public IP address, friendly name, I'm calling it as a Bastion host. Just give a double click. Default username is administrator. Click on connect, RDP client, get password, upload private key. On my desktop under key pairs folder, I have my Windows KP, decrypt password. I'm grabbing the password, giving the password here, click on continue. All right. So we have successfully connected to our custom VPC public subnet EC2 instance. Okay. Now I want to get connected to my private subnet instance. So yesterday, our private subnet instance is a Windows one. So what we did, so directly MSTSC application is available, remote desktop application is available. So we have taken Windows or MSTSC. given the public IP address, and we got connected to it. But my private subnet instance is a Linux one now. So what I need to do? If I want to get connected to a Linux instance from our Windows machine, so what application we need to have? Okay. PuTTY, OpenSSH. By installing OpenSSH, we can use command prompt, or we can install PuTTY application within the server. We can use that. So first thing, we need PuTTY. Second, another important thing is key pair. We need to have key pair within this machine, right? Currently, where is the key pair? In my local laptop. But I want to connect from this machine to private subnet machine. So do I need key pair in this machine or not? Okay, so this is the logic you need to understand. That's the reason I've taken Gem server as a Windows. If I taken both Linux, you will get confused. Okay, so first, what key pair required to connect to my instance? Let me take that key pair. So the key pair is my Linux KP. I'm copying that key pair to my Windows machine. If we don't copy here, what happened? We cannot get connected to it. Okay, so that is an important thing. Tomorrow, we will discuss with both Linux systems. There also, I need to copy key pair to Gem server. Okay, so this is the logic. Now, let me download PuTTY application here. You can download in your local laptop and you copy here, or you can download from this machine also. If you want to download something from internet, you know, whenever you open google.com, what happened? It is going to give a lot of security, like, you know, IESC, Internet Explorer Enhanced Security Configuration is enabled. It will ask us to, I'll show you that. Now, if I access google.com, you see what happens? Okay, security alert, give okay. Now, another pop-up will come. You see this pop-up? Okay, we need to add this. We need to add. So we need to add this one also. So then it is going to, like, you know, so we always need to add this. Then only the web page is going to load. Okay, it picked something, some another website. Maybe some typo. Okay, see, I really don't want to get this pop-up. Whatever website I'm accessing, I know that is a trusted one only. So what we can do is go to start. This is not mandatory. If you're okay to close that window always, you follow that. But I'll, like, you know, I don't want to see that window for every website. So to close that, go to server manager. And in left pane, you have local server. And right side, you have an option called Internet Explorer IESC, Enhanced Security Configuration. Just click on this, turn it off, at least for administrator. Turn it off. Now, if you are trying to access any website, it won't give that pop-up. So let me open this Internet Explorer now. I'll download PuTTY application here. The website is putty.org. Download PuTTY. Okay, I'm going to download the installer instead of double click and run. Run. Next, install. Finish. So now PuTTY application successfully installed. Now what is the process? So first, open PuTTY application, go to start, search for PuTTY. It's taking some time. So here is a PuTTY application. Just expand. Here is a PuTTY. Take that PuTTY. Host name is nothing but our instance private IP address. Go here. grab your private subnet instance, grab the private IP address of it, give that private IP address, port number 22. Under connections, expand SSH, select authentication, expand authentication, credentials. Okay, here private key file for authentication. Click on browse, but our key pair is in PEM format. So if you select all files, it is showing PEM format. I want to convert it to PPK. So you know the process, right? Depend on Puttism. So go to start, Puttigen. Load. Select all files. Select PEM file. Open. Save private key without any password. You give any name. Okay. So then save. Now the file got created. I'm selecting that PPK file. Click on open. Accept. Login as EC2-user. We got connected to this machine. So now, do we have internet within this machine? No, we don't have internet within this machine. How we can verify? You remember any command? Duplicate google.com. Duplicate go to google.com. It's connecting to google.com, and is it working? No. Okay. It's not working. So no internet, but we are able to get connected to private subnet instance now. So far we performed yesterday, but only difference in yesterday's and so far what we discussed. Yesterday we have taken this as a Windows machine. So today we have taken this as a Linux machine. That is a only different thing. Nothing new configured so far. So if you guys are good so far, we will start today's topic. Any questions? No questions, all good? All right. So now my requirement is, see, this is my private subnet EC2 instance. And I'm running some application within this EC2 instance. That application required some, like, data that is available over the internet. But do we have internet within this machine? No. Even, for example, some OS updates available. So if I run sudo, okay, or just yum install, I want to make it as a web server. Yum install httpd. If I gave enter, is it working? No. Why it is not working? No internet. The package is not able to download from internet. So without internet, we cannot download anything. We cannot install anything. We cannot access websites like Google, or we cannot access anything that is available over the internet. You see this? It's not available. It's giving an error. Okay. So my requirement is I need internet for this machine. But again, I don't want to compromise in that security thing. I don't want to make it as a public subnet. If I make it as a public subnet, whoever over the internet they have, right, they can access it. So then what is the option we have? So that is a NAT gateway. We have an option called NAT gateway. We can create a NAT gateway. We can associate that NAT gateway with private subnet root table. Okay, what are all the subnets associated to that private root table? They all will get internet without any public IP address. NAT stands for Network Address Translator. Okay, so where that NAT runs actually? So if you're taking it in diagrammatical manner, so the NAT actually runs in our custom VPC's public subnet. So it runs either in this public subnet or any other public subnet. Now you might get it out, okay, From where the NAT will get internet? NAT will get internet from internet gateway. So what this NAT will do? It provides internet to both the private subnets. Okay, it gets internet from internet gateway. It acting as a intermediate one. Directly, it is not sending any traffic to internet gateway. Why? Because we don't have a public IP address. So this will have a public IP address. It will maintain a root table. Okay, this device is trying to access google.com. It comes here, this sends here, it goes to Google, Google sends here, this sends to NAT, NAT sends here. Your instance directly not communicating. It acting like a intermediate one. It acting like an intermediate or broker. Okay. So one thing, this NAT actually runs in our custom VPC public subnet. Why it need to run in public subnet? It need to have access to internet gateway. If you run it in private subnet, no. Okay. So that is a reason. Now I'm going to create one NAT gateway. For example, your private subnet EC2 instance count is huge. Okay, you have a lot of EC2 instances. So for high availability purpose, can I have multiple NAT gateways? Yes. So for example, one NAT is running in one public subnet. Another one NAT you can take and you can associate it here. This is possible. But one thing, can we have multiple internet gateways to a VPC? No. But we can have multiple NATs. Okay, I'll create one NAT and I'll test it. Okay. So navigating to VPC. In left pane, we have NAT gateways. Go to NAT gateways. Okay, click on create NAT gateway. Give a name. So my custom VPC NAT gateway. In which subnet you want to run this? I'm going to run this in public subnet 1A. I'm running it in public subnet. You see here, as per the diagram also, it is running in one of the public subnet. Either this public subnet or this public subnet doesn't matter. It should be in a public subnet. Okay. So connectivity type is public. Why? Because we want to access outside, like, resource also. And it need an elastic IP address. And you remember, elastic IP address will cost us. So NAT gateway will cost us. I'm going to explain here, allocate elastic IP address. One allocated here. Scroll down and click on create NAT gateway. So now what happened? When NAT gateway is created, okay, it will take 1 minute to come to active state. Now we need to modify appropriate root table. Now the question is, which root table we need to modify? Navigate to root table. We have private root and we have public root. Which root table we need to modify? Private? What is the logic behind that? We don't have internet to private subnet resource only. For public subnet, we already have internet gateway. Do you again need another component to provide internet? No. It already have internet gateway. So not required. So go to private root. Navigate to routes. Okay, let's test this. So I still don't have internet here. I'm trying to install, it's not happening. And I'm trying to run this wget google.com, still not happening. Okay, so let me go back here. Where is that? Okay, here is the root tables. Navigate to private root table, edit routes, add route. I want to allow all the traffic coming over the internet via NAT gateway, and select the NAT gateway and click on save changes. Now what happened? whatever the requests are coming from these subnet EC2 instances, it goes to NAT gateway. Okay, it sends the traffic outside. So we can access internet now. Let's verify this NAT gateway status. It is still pending. It is still pending. We need to get it in running state, then we can test it. Okay, it is in available state. So now I want to test it. Sometime back, when I tried to access google.com, it's failed. Now I'm giving wget-google.com. Working? Working. Earlier, when I tried to install something, for example, yum install httpd, it failed. But now it's happening. So we are able to access internet. We are able to access internet from this private subnet EC2 instance. Agree? Which component is giving? NAT gateway. Where NAT gateway is running? In custom VPC public subnet. From where it is getting internet? NAT gateway. From internet gateway. From where our instance is getting internet? NAT gateway. So now, do we have any public IP address for this machine? No public IP address. Is it public facing? Can we get connected to this instance from our local laptop? No, but still we are able to access internet. Okay, so this is the NAT mechanism. Okay, so any questions on this NAT gateway? It will cost us. I'm repeating this multiple times. NAT gateway will cost us. If you try it, make sure you release elastic IP address also. Deleting NAT gateway won't delete your elastic IP address. Delete your NAT gateway, go back to elastic IPs, delete your elastic IP also. Okay, so then only the cleanup process completed. Okay, clear so far? So now, in real environments, we use same component. But earlier, we used to have another component called NAT instance. I'll explain that, but you don't talk about that in your interview. Don't add that in your resume. It's an earlier process. It comes under pre-tier eligibility. I don't want you guys to pay something for this NAT. So we have some tasks. Okay. So there I want you to run some resource in private subnet. So you better practice with NAT instance, not with NAT gateway. Okay. So I'll delete this NAT gateway. Why? Because even my account also will get charged. So just type delete. So NAT gateway is now deleted. So immediately, if you try to access this, till it is happening. Since it's not deleted yet, it's in deleting state only. So it won't work. So my main thing is what I'm trying to show here is, so once NAT got deleted, you cannot access any internet. Okay. Still. Okay, let's use wget-google.com. Yeah, you see, connecting to google.com, it's not happening. So it stopped working. Internet is stopped working. You cannot access anything. All right. So that is a mechanism, NAT mechanism. So this is deleted. Now it's deleted. So what you need to do, go to Elastic IPs, release this. Otherwise, you will get charged for that $3.5 per month. $3.5 per month you need to pay. Okay. So that is a NAT gateway. Now, what is the alternative option we have? NAT instance. So NAT instance, we don't use in real environments. Earlier, we used to. Around 4 years or 5 years back, we used to. But now we are not using. The reason is you need to launch an EC2 instance to perform this NAT operation. Okay, you need to pay hourly basis. And if you are getting slow internet, you need to increase your instance configuration. If someone modified your instance security group, internet stop working for all our private subnet instances. Again, just like this NAT gateway, okay, in place of this gateway, we are going to have an instance. Okay. In place of this NAT, we are going to have an EC2 instance. That's it. Okay. So that is again going to take internet from internet gateway, it will do. But you need to take care about instance configuration. You need to take care about security groups. You need to take care about another setting called source and destination check. Okay. So 3 things you need to take. It's an additional burden for us. Okay. So, but you see NAT, did we perform anything? We just created, it scales automatically. You just pay data transfer and $3.5 for Elastic IP. Everything AWS managed. But if it is an EC2 instance, you need to take care about OS patches, additional burden, lot of things, right? That's the reason we stopped using that NAT instance mechanism. Okay. So, but it comes under free tier eligibility. That's the reason I'm explaining. So click on launch instance. I'm calling it as a NAT instance. I'm taking, go to browse more AMIs, go to community AMI, search for NAT. Search for NAT here. So then you can find some NAT instances. So select the first one. You see from 2018 onwards, it stopped. Okay, I'm selecting it. So that operating system have modified. Operating system is modified to perform NAT operation. T2 micro, I am selecting my Linux KP and where it need to run. Custom VPC, public subnet, just like a NAT gateway. NAT instance also need to run in custom VPC public subnet only. And security group. Security group must open with STTP and STTPS for anywhere. Why? Why? Because whatever the instance you have here, it is trying to access internet. Whatever instance you have here, it is trying to access internet. So first what happened? It goes to NAT instance we have here. This instance security group is not opening with HTTP. So can it send traffic out or whatever traffic coming from out, will it send here? No. And 99% of the websites run with HTTP and HTTPS protocols. Okay. So we must open HTTP and HTTPS. Then only it works. Otherwise it won't work. Okay. Scroll down. Launch instance. Now an EC2 instance is launched in our custom VPC private subnet and the AMI is NAT AMI. Okay. So fine, it created. We need to disable the source or destination check. What is the logic behind the source or destination check? The logic is very simple. I want to send some traffic to this guy. Okay. So how I am sending? With the help of an intermediate guy. For example, I'm giving this and I'm asking him to pass it to him. Okay. So now, do I really want to pass it to this guy or that guy? This blue t-shirt or white shirt? I want to pass this remote to that second row guy. Okay. So I cannot go there and I cannot give it to him. So what I'm doing, in between, there is a guy sitting in first row with blue t-shirt. What I'm doing, I'm asking him, okay, I want to pass this remote to the second row white shirt guy. I'm giving to this blue shirt guy, and what he is thinking, okay, Avinash is giving to me only. I don't need to pass anywhere. Okay, now my request is fulfilled. And vice versa. Similarly, that white shirt guy want to pass something to me from second row. There is one guy sitting in first row and he want to, he hand over to first row guy. And again, that guy is thinking, okay, I'm the Avinash. I don't need to pass to anywhere. But is he really the Avinash? No, right? So similar way. So we have an EC2 instance here. We have an EC2 instance here. This is trying to access google.com. Okay, it is running in private subnet. So what happened? The request will go to NAT. Now, is this NAT instance hosted google.com? No, right? It should not act as a source or destination. It is just an intermediate one. So it need to send the traffic out to google.com. And while Google is giving response, again, it should not act as a destination. It should simply send here. So the intermediate instance is not source nor destination. So this blue t-shirt guy is not the source nor destination. If I want to pass it to him, he need to pass. If he want to pass something, he need to pass it here. So that is a logic. Okay. By defaultly, every instance will act as a either source or target, source or destination. Okay. So we need to disable it. If you don't disable, it won't work. Okay. So if you deploy NAT, if you are not able to provide internet to private subnet instance, I'll ask three things. First, is your security group opened with HTTP and HTTPS for everyone? Second, is your EC2 instance disabled with source or destination? Check. Go to your instance, actions, networking, change source or destination. Check. It's enabled now. Stop it. So, then click on save. Now what happened? When we go here, this specific EC2 instance don't act as a source or a target destination. Okay, so that is another important setting you need to take care whenever you are working with NAT instance. Okay, 2 steps completed. What is the third step? Edit appropriate root table. Again, which root table you need to? Go to root table. Which root table? Private root. So the existing root is showing as a black hole. What is a black hole? What exactly black hole does? Absorbs everything. Whatever goes inside, the gravitation power takes, it never comes back. What wormhole will do? It opens tunnel to another galaxy, right? Or another location or parallel universe. No one went through it, right? So, here it is showing as a black hole. So that means whatever the traffic coming from these 2 EC2 instances now, this NAT gateway is not available. So the traffic goes nowhere. Okay. Why? Because we deleted it. That's the reason. Remove, add root. I'm allowing everything via instance this time. Earlier, I have selected NAT gateway. Now select instance. Select your NAT instance. I'm not applying save changes. Before that, I'm trying to verify. Is internet working? No. It's not working. Now I'm going to save changes. Okay. So now go back here. Just try to access internet. Now it is working. You see? So the NAT instance this time is providing internet. Okay. 3 things. First, make sure your NAT instance is open with HTTP and HTTPS. Second, make sure you disable source or destination check. Third, you modify private root table with NAT instance. These 3 things. And the first thing, you launch NAT instance from community AMI. It is free. Okay. So these are the 4 things if you want to work with NAT instance. As I told you multiple times, in real environment, we don't use this. That NAT gateway don't comes under free tier eligibility. That's why we are discussing it. You mention in your environment you are using NAT gateway. Okay. But don't talk about NAT instance in your interviews. Okay. Right. Any questions? I'm open to your questions now. Looking like a complex topic? No? Simple? Okay. Good.
Yeah.
Hi, Amish.
Yes, please.
Yeah, we are using NAT instance, right? In that any
Yes.
software has been installed for routing this traffic. Is that anything?
So basically the AMI itself, whenever we are launching, right? So here, so AWS itself already prepared this operating system to perform NATing. So basically, yes, it required some OS level additional modifications required. Okay. So those all modifications already did, and AWS made it as available for us. So simply we are taking it and we are using it. Yes, definitely additional softwares installed, additional modifications happened within that. Okay, it's available as an AMI. We are using it.
Okay.
Okay. Yeah. All right. So that is a NAT mechanism. So clear with this? So without making an instance public also, we can provide internet. Okay, this is a repeated certification question. I'll show you questions also. So if you're good so far, we will discuss next topic. Good? All right. So next topic is we have VPC peering. And before that, we have an option to enable logs. So basically, I'm deleting this. You're good with it, right? Can I delete NAT?
Hello, sir.
Okay. Yes, please.
Sir, sorry for the interrupt. Good morning, sir. Sir, example, without routing table, we need to directly reach either a private subnet or public subnet, sir. That is mandatory. Yeah?
See, route table is definitely mandatory.
Mandatory.
Without the traffic routing is happening with the help of route tables only, right? So where we are making a subnet as a public or private, at route table level only.
Route table.
So route table is mandatory.
Okay. In route table, we are giving the information about which IP they are reaching that one like that, sir.
In route table, if you observe, I'm opening for everyone. Via internet gateway, I'm opening for everyone. For example, with the help of internet gateway, you want to access only google.com, you gave Google IP address here. So currently I'm opening it for everyone.
Yes, sir. Yes, sir.
Yeah.
Like that, which one is accessing through subnet? We can use that routing table.
See, whatever the instance you have within this subnet, first of all, you need to do subnet association.
Okay, sir.
We have 4 subnets. I have added 2 public subnets here.
Yes, sir.
So within this public subnet, whatever the instance you have, if it is accessing any website, what happened? It will look for the route tables. So there is a route available via internet gateway for every traffic.
Okay.
So if you are accessing google.com or facebook.com or YouTube, all the traffic is allowed via this internet gateway to this private subnets.
Okay, sir.
Okay. Similar way, this private route is there, right? Whatever the subnets you have here, okay, this subnet, if it is trying to access internet, the request will come to EC2 instance, NAT instance or NAT gateway, and it goes out. Okay?
Okay, sir.
Yeah.
Yeah, fine, sir. Thanks.
Yeah.
Sir,
Yes, please.
sir, this VCP concept, is it comes under free tier eligibility or it will charge us if we create?
Apart from NAT, see, only this component comes under chargeable. Remaining that's the reason I explained NAT instance, right? It won't comes under free tier eligibility. It comes under free tier eligibility. This NAT gateway only don't comes under free tier eligibility.
Okay.
Yeah. Creating VPC, creating subnets, creating route tables, creating internet gateway is free.
Okay. Thank you.
Yeah. Right. So now, see, I want to enable logging. So logging is always important, guys. Logging is always important. So if you want to enable logging, like, we have multiple options. One is you can enable logging at VPC level. Okay. We can enable logging at subnet level. For example, for this public subnet only, you want to enable logging, or you want to enable logging at one of the EC2 instance level. Okay. So you observe, one is at VPC level, we can enable logging. So what happened whenever you enable logging at VPC level? VPC, within that all subnets, all instance logs will store. If you enable at this level, what happened? These all subnets will come, all instance will come under this logs. So that is one. For example, I don't require logs from VPC level. I decided to enable logging at subnet level. Yes, we can. So how many EC2 instances we have here? All those EC2 instance logs will come if you enable it subnet level. Even I don't require it from subnet level also. I want to enable logging for only one individual EC2 instance, as that is important. Okay, so still we can go and we can enable logging for one individual EC2 instance also. Okay, so that is the mechanism of flow logs, VPC flow logs. All right, so it depends on client. We can apply logs at entire VPC, subnet or instance. I'll show. Steps are same. There is no difference. Steps are same or process is same. So if you want to enable logging at VPC level, go to VPC. There is an option called flow logs. You see here, there is an option called flow logs, or go to actions. The second option is create flow log. Click on create flow log. What is the name you want to give? Okay, my custom VPC logs is the name I'm giving. Now, what type of logs you want to store? I want to accept all the logs, only accepted logs, rejected logs, or all logs. I'm selecting all. Maximum aggregation interval. So the pocket capture, how frequently it is happening. So we can take 10 minutes or we can take 1 minute. Now, where do you want to store these logs? We have S3 option. We have CloudWatch logs group option. So we can go and create a log group and we can use that here, or we can select an S3 bucket and we can give the bucket ARN here. And what is the format? You select the format, and so partition logs by time. So it is going to partition, like, make small parts for every 24 hours or for every 1 hour. So then create log group. So entire VPC level logs are going to store in an S3 bucket. If you want to view, if it is an S3 bucket, right, we need to download, we need to view, it's a bit difficult. So what we can do is, we can use the send to CloudWatch logs. We can easily view that log. Navigate to CloudWatch. First of all, you need to create a log group. So in left pane, we have an option called logs. Then in left pane, we have log groups. Go to log groups. Click on create log group. The log group name is custom VPC logs is the name I'm giving. Log retention period. You know what is retention, right? I want to store only last 5 days logs or 7 days logs, or logs never expire. Then create. Now go back to VPC. I want to store all the logs into this custom VPC logs, and it need a role. So there is a role called flow logs role. Create that role. Click on setup permissions, or you will find flow logs role. Select that here. So then you simply go here, create flow log. All your VPC logs will store in this logs group. We can read, we can view in the console itself. Okay, so that is another option. And we have one more service called Kinesis. So that we will discuss later. Okay, so that is at VPC level. If you want to enable it subnet level, go to subnets. We have 4 subnets, right? I want to enable logging to only one of the public subnet. Select that subnet. Okay. Actions, create flow log. Console and options and everything is same. So how many instances you have within this public subnet, only those instance logs will store. Okay. So that is a one option. And when coming to individual EC2 instances, for example, this jump server is very, very important to me. I want to enable logging only for the jump server. So in that scenario, go to network interfaces or just click on networking. Select your instance, go to networking, scroll down. Here you can find a network interface. Open that network interface. This is a network interface. Select it. Actions. Last option is create flow log. Again, all options are same. But it captures only one instance log. Previous one, it captures one subnet log. The first one, it captures entire VPC logs. Okay. What we can do with this logs? We can inject that logs to different applications, third-party applications. We can get some graphs, how many accepted ones are coming, how many rejected requests are coming, who is accessing the server, from what network they are accessing, all that information we can get. Okay. So that is a mechanism. Right. So remember that service name. What is that service name? Our option name? VPC flow logs. For our load balancer, what is the log name? You remember? Access logs. For our load balancer, we call it as a access logs. For VPC, we call it as a flow logs. Clear? Right. Enabling that logging is free, but where you are storing, that is matter. There you need to take care whether you are under free tier eligibility or not. You are within free tier limitation or not. Just remember that, okay, you can't do anything with that logs in your accounts. Right. So that is a flow logs option. Now, so you have enabled flow logs, and what happened? You are observing some unnecessary traffic is coming from one of the specific network. So then what we can do? One of the unnecessary traffic is coming. So, I decided to restrict that. The traffic should not reach to my EC2 instance. Okay. So we have an option called firewall at subnet level. That is a network ACL or NACL, NACL. Network Access Control List. Network Access Control List. What this network NACL will do? It filters the traffic at subnet level only. So, the whatever traffic coming from outside world, for example, someone is trying to access something from this EC2 instance. Okay, the request is coming, okay, via this network, and it is coming to this particular subnet. So what we can do, we can implement an option called network ACL here. Whatever traffic coming from outside world or anywhere, the traffic blocks here itself. It won't reach our EC2 instance. It's act as a firewall. You know what firewall is, right? So at instance level, what is firewall? Security group. Security group act as a firewall at instance level. This network ACL act as a firewall at subnet level. It act as a subnet level. So this is a security group. Whatever instance we have, okay. So this security group, this is a EC2 instance. We can give a right click and we can send it to back and we can move this instance and all. All right. So this is our security group. It acting as a firewall at instance level. But now I decided to apply network ACL. Okay, this is a symbol of NACL. So what we can do, we can add NACL at this subnet level, or we can add NACL at any subnet level. Now what happened? What are all the instances you have? Not just one, you might have 2 instances or 3 instances, right? So before traffic reaching to this EC2 instance, it need to validate with this network ACL. If it is okay, then only traffic will go to your EC2 instance, otherwise it won't go. Okay, so this is again similar to security group, but at subnet level. Couple of differences. Security groups, we always need to take care about inbound rules. Have we worried about any outbound rules in security group? No. We always taken care about inbound rules only. But when coming to this network ACL, you need to take care about inbound as well as outbound rules. You need to take care about inbound as well as outbound rules. So 2 things you need to. Okay. So I'll quickly do one thing. I'll make this EC2 instance as a web server. I'll deliver some web page. So start. So as this is a Windows instance, what I'm doing? I'm installing IIS. Add roles and features. Next, next, next. Select web server. Add features. Next, 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 install. So it become web server. So again, we can create a custom web page and we can deliver that. So currently, what is the network ACL of this EC2 instance subnet? It is running in one of the public subnet, right? What is the network ACL of this one? That is a default network ACL. Whenever you create a VPC, defaultly it creates a network ACL. It creates a default network ACL that allows all the traffic. No DENY, no restriction, nothing. Okay. So that's the reason we can access it. I'll show that. Meanwhile, I'll verify. Do I have any index.html? I think no. I'll create one. C inetpub www root. Okay, the installation is completed, index.html is created. So how to test it? Just grab that instance, public IP address, give that here. It's not working. So what you need to verify? Security groups. Go to security group, edit inbound roles, add roles, HTTP. I'm opening it for anywhere. Save roles. Go back here. Give a refresh. It's working. Okay. So now my security group is allowing to access this web page for everyone. Not only that, even I'm able to get connected to it. Why? Because RDP is open for everyone. So at subnet level, if I go to this network ACL, what are all the subnets I created? That public subnet, private subnet, public 1, public 2, all 4 is associated to this network ACL. And that is allowing all the traffic in inbound as well as outbound. So that's the reason no filter is happening at subnet level. Whatever the traffic is coming, it is sending to EC2 instance. Now I want to add some filter here. What traffic I want to allow, only that traffic should reach my EC2 instance, not all the traffic. Okay. So for that, I can add rules in inbound as well as outbound. Why? Because network ACLs are stateless. Stateless means we need to take care about inbound as well as outbound. Stateful means we need to take care about only inbound rules. Security groups are stateful. Security groups are stateful. Network ACLs are stateless. Okay. Security groups works at instance level. Network ACL works at subnet level. All right. And do we have any DEMI option in security groups? No. To what network you want to make it available, you give that IP, it will be available. But when coming to network ACL, yes, we have a DEMI option. We have a DEMI option at network ACL level. What traffic you want to DEMI, to what network you want to DEMI, we can do that. Okay. So let's click on edit inbound rules. Whatever the traffic you want to allow, we can go and allow that. And AWS recommend us to give these rules increments of 100. There is a reason, I'll tell you. Okay. So rule number 100, instead of modifying default one, I'll create a new one. Create network ACL. Custom VPC NACL is the name I'm giving. I'm selecting my custom VPC. Create network ACL. You see here, 4 subnets here, no subnets in newly created one. Go to newly created network ACL, subnet association, edit, select your subnet, public subnet 1A, then save changes. Now, if I go here, if I give a refresh, you see here it's trying to load, and it's failed. Why? Because this EC2 instance running in a subnet that is added to newly created network ACL. And is it allowing any traffic? Nothing is allowed. So even you see here, connection also lost, website also not working. Why? Because my traffic is blocking at subnet level. It is not even reaching instance. Clear so far? Now, what traffic need to reach to my EC2 instance? I need to open that ports here. Then only that particular traffic will reach my EC2 instance. Edit inbound rules. I'm going to open port number. Okay, it's RDP, right? So the rule number 100, RDP, opening for everyone. Rule number 200, even this website is delivering with HTTP. So I'm opening HTTP. Okay, then save changes. I'm opening only 2 ports, 2 protocols to reach my EC2 instances. Go to outbound rules. I'm opening the required one. Rule number 100, that is RDP. I'm opening for everyone. Rule number 200, that is HTTP. I'm opening for everyone. Still, it won't work. The reason is AWS Network ACL uses ephemeral ports. Ephemeral means? Ephemeral meaning? What is instance store? Another name. Instance store volumes, right? We even call it as a ephemeral storage, right? So what exactly ephemeral means? Temporary. So this network ACL also will use temporary port numbers. It will choose port numbers randomly. We need to open that ephemeral ports. Then only it works. So ephemeral ports are, go here. I'm giving rule number 300. Okay. So custom TCP, ephemeral ports are 1024 to 65,535. Okay, I'm allowing. It is must. It is must. I'll share an AWS article also on that. Don't ask me why it is must. I too don't have an answer. I'm following AWS. I tried to. I did lot of research. Anywhere, ephemeral ports are mandatory. Ephemeral ports are mandatory. If you are using Windows, 1024 to 65,000. If you are using load balancer, 1024 to 5,200 something. But no justification available. Right. So save changes. Now, if I go here, if I give refresh, it is working. And this connection also restored now. You see here. Why? Because my network ACL at this level, RDP is opened. STTP is opened. So RDP traffic and STTP traffic is reaching these EC2 instances. No other traffic is reaching that EC2 instances. Okay, so now my requirement is I'm getting some unnecessary traffic from this Naresh IT network. This is Naresh IT IP address, right? I'm getting some unnecessary traffic from this particular IP address. I want to block it. That too, I want to block STTP requests. So what we can do is go to your network ACL, edit inbound rules, which traffic I want to block, STTP, add a new rule. Rule number, I'm giving 201. Which traffic? STTP. Okay, to what network? I'm giving that IP address, class 32. Do you want to allow or Denny? Denny. Then save. I'm going to do same in outbound rules also. Edit outbound rules, add rules, 201, STTP. I'm going to Denny for this network. Now, as per this configuration, what happens, rule number 200 is allowing for everyone. And rule number 201 is Dennying for one particular network. So, what happened? If we go and if we try to access, it still works. The reason is lowest rule number will have highest priority. Rule number 201 is Dennying, but rule number 200 is allowing for everyone. So obviously 200 will take effect. So if you want to make this work, what we can do? Make it as 199. Edit, make it as 199. Save rules, go to outbound rules, make that as a 199. Now what happened? Rule number 200 is allowed for everyone. Rule number 199 is denied. So apart from that particular IP address, everyone can access this web page. Let's test it. I'm navigating here. Give a refresh. It's not working. And I'm posting that IP address in our chat box. Just click on that link. You will get the web page. Just click on that link, you will get web page, but it won't work for me. You see here, it's not working for me and it is giving a timeout error. So what is happening? My request is going, but subnet is stopping that request. All your requests will go. If you gave your public IP address, I can block it. Okay. If you gave your public IP address, I can simply go and add another rule. I can add 198. I can give IP address. I can set it to Denny and you won't get the web page. Okay. So similar way, you can block n number of the IP address here without reaching the please be on mute, guys. Without reaching the traffic to EC2 instances in that specific subnet. And any conflict may happen? No. The reason, one subnet can be member of one network ACL at a time. Earlier, we have 4 subnets here, but that one subnet is came to new network ACL. Okay. So, anyone tested? No one tested?
Yes,
No
sir.
response? Okay. Yeah. All right. So, that is a network ACL concept. So, in real environment, only some clients I have seen who uses this, not all the clients. See, some clients who want to make their application public facing, they rely on this feature. But some clients, they really don't want to use any public IP address. They don't want to make their application public facing and all. They will use some hybrid methods to deliver it. In that scenario, we don't use this network ACL. For example, in my project, no, we are not using it. But in previous project, that's a public facing one. Yes, we have used it. So you need to know the concept. One important thing is network ACLs are stateless. We need to take care about inbound as well as outbound. Okay. Security groups works at instance level. It called as a firewall at instance level. Network ACL act as a firewall at subnet level. Security groups don't support any operation. It only allow, but network ACL supports allow as well as any operation. Okay. So lowest rule number is going to have highest priority always. For example, now it is blocking right here. So what I did, I have edited this inbound rule and I'm giving rule number 10. Okay. So that is allowing traffic for this IP address. Now what happens? So you see here, rule number 199 is denying. Rule number 10 is allowing. So which one is going to take effect? 10 only will take effect. And you really don't need to maintain same range. Right. If I go here, see it's working. Why? Because that rule number 10 is taking effect. So important thing is lowest rule number will take highest priority. Yeah. So that is a network ACL concept. Right. One subnet can be member of one network ACL at a time. So any questions on this network ACL or NAT mechanism?
Ganesh, regarding this network ACL,
Yeah.
if we want to deny for multiple IP addresses, so we need to create a subnet and add it.
So first of all, if you want to block, so at subnet level, you create a new network ACL and associate that subnet first. So then you add rules in inbound as well as outbound. What traffic you want to allow or deny? So open that port and you start adding deny for the IP addresses. How we will come to know some unnecessary spoof traffic is coming? With the help of logs, VPC logs, right? Yeah.
Thanks.
Okay, I'll share this VPC image and I have a task, guys. So the task is so first of all, take a VPC. Take a VPC. Within this VPC, you have AP South 1A and 1B. So these dots are representing this is 1A and take another one.
This is AP South 1B. Now, I want you to create 4 subnets, 2 public subnets, 2 private subnets. So public subnets is in this green color. What class, what CIDR range you are taking doesn't matter. Okay, so create one public subnet, create another public subnet. Okay. So once this is completed, create 2 private subnets. I'm taking it in some, okay, red color or it's orange, right? Create one private subnet. Obviously, how it will become public, how it will become private, internet gateway, NAT gateway, that I am not mentioning. Now, launch a EC2 instance in one of the private subnet. Launch an EC2 instance in one of the public subnet. If you are okay, you can launch one EC2 instance in one public private subnet, another EC2 instance in another private subnet. Make both as a web server. I want you to make both as a web server. Now you might get a doubt. Hey, Avinash, you're asking me to make it as a web server. How I can provide internet? How we can provide internet to private subnet instances? NAT. So create a NAT instance. Create a NAT instance. Now to install at least, we need to get connected to it, right? How we can get connected to that? How we can get connected to the private subnet instances? From your local laptop. You are working from here. This is your local laptop. How you can get connected to it? Jump server. So take a So from your local laptop, connecting to Jump server. From Jump server, you connected to these 2 EC2 instance and make it as a web server. Fine, clear so far? Okay, if you want to make it as a web server, it need internet. So create NAT instance. I'm stressing this, create NAT instance, not NAT gateway. Don't come back again and asking me to, I'm getting charged and all. Okay, so now create a load balancer. Just observe where I'm creating this load balancer. Load balancer is spreading across public subnets. Whatever 2 instances you have created, you made it as web servers, right? Add both web servers to this Elastic Load Balancer. Take application load balancer. Add both to this load balancer from your local laptop. If you are trying to access this Elastic IP address, Elastic Load Balancer, it should give, okay, it should give output. Whatever web servers you configured here, right? You should get that output from here. Where your web servers are? Private subnet. Without directly accessing that private subnets, via load balancer, you're accessing output. To perform that configurations and all, you're depending on Jump server. So is this clear? Any questions on this diagram?
I'm not clear about creating Jump server.
Sorry?
Creating Jump server in public subnet.
Yeah. So how you can get connected to this EC2 instance and how you are going to install the packages? So for example, where is that? So this is my private subnet EC2 instance. I asking you to make it as a web server. So I need to run some commands. I need internet. For that internet, I required NAT. And what I'm asking you to make it as a web server. So without connecting to it, how you can make it as a web server? So obviously you need to get connected to it. So to get connected to it, you need Jump server. Without that, you cannot. Okay. Yeah. All right. So this is a task. It's important. Why? Because we are going to add load balancer on top of this. So all these steps are here, step by step. We have completed till here, till network ACL. We have endpoints, VPC pairing. So that we will discuss in our tomorrow session. You guys are okay to have session tomorrow, right? No? Yes. Okay, thanks. Everyone, okay, right? Okay.
Yes, sir.
Thanks, guys. All right, so that is a custom VPC mechanism. I'll do one thing. I'll keep these two resources in stopped state instead of okay, however, tomorrow I need to launch Linux, right? I'll terminate it. Right. So, yeah, that VPC task diagram also I'll share over the GitHub. All right. All right, spend some time and please practice, guys. With one more session, we're done with VPC. As I told you, VPC is just a 3-session topic. Okay, next week we discuss database. Then all module-wise topics completed. Okay, database is hardly 3 sessions. Right. So then module-wise topic completed, all small and individual, module-wise topics only, all are small topics. 15 minutes, 30 minutes, one topic done. So such type of topics, not a module, not dependent on like EC2 and this VPC and all. Okay. So please spare some time and practice. See you again tomorrow, guys. Thank you.